Welcome to Machine Elements, MET 314. Glad to have you. Taught this course for quite a while now. I should have looked it up before I started with the recording, but I don't remember how long it's been. It doesn't matter. It's a very different course from the ones that you may be used to. We'll get into that a little more, but I think you'll like it. I know I enjoy teaching it, and I enjoy the topic, but it is very different from many courses. It actually builds quite a lot on many of the courses you've had. Dynamics, strength of materials, even statics. There's a lot to those courses, and of course your materials classes that come into play here in this course. Of course, this semester is a little different than our usual one. I intend to deliver all lecture videos via pre-recorded YouTube videos. I will link them in Blackboard, or excuse me, not Blackboard, Brightspace, of course, which is what we're using this semester. It's what I'm on right now. And you'll watch them there. Now there will be a little quiz at the end just to make sure you've watched the video, and the way it works is that the quiz will be due an hour or so after the class period would normally end. So what I found in the past in teaching distance courses and courses at the end of last semester is students don't really feel urgency, I guess, to watch videos and to get their work done. I know you guys want to. I understand that. But things happen, and unless I set due dates, you may not stay on track. So I'm just trying to help you stay on track. The idea of the quiz is not that the quiz is going to be some hard calculation you have to go through. It's more just, did you watch the video? Now that's it. I've actually used that as the question in the past. Did you watch all the videos? As the quiz questions. They're going to be a little more in depth this time, but not too bad. It's nothing where you have to, write down a whole bunch of notes or anything like that. It's more just low stakes quizzes. Now, the first class, you're all welcome to attend, assuming that you've got your clear COVID test and you're in compliance with the guidelines that protect Purdue. But you don't have to. In fact, that's why I'm recording this introduction. That's why I'm recording the lectures, because I knew that things were going to happen and things wouldn't necessarily work out like we'd planned. And that's okay. I want to make sure you guys can get all of the information in the course and that this will all work out. One thing I'm going to do, by the way, I am going to try and make sure that I'm in my virtual room all the time. At this point, my plan is to use WebEx. I may switch over to Zoom at some point. I know that Zoom's supposed to be integrated into Brightspace, but I don't believe that's happened yet. So I'm going to use WebEx because I'm familiar with it, and it works. It's easy. It's well supported. But it's a virtual room, and so the idea is while you can't come into my office and I won't be with you in most classes, you can come into my virtual room, and we can, video conference, and we can talk about whatever you want in the class. I can certainly help you out. So I'm going to have basically an open door policy in the sense that you can come in pretty much any time. Now my schedule, I think we've pointed out, there's one more thing here. My schedule I'll point out here in just a second in the course. I've posted it for you so you can kind of tell where I'm, what I'm kind of focusing on at times. Alright, what else did I note here? Our current roster is 13. I don't know if we'll add or subtract students from that, but only 12 are allowed in our room. So the first day my plan is to just kind of give the introduction to whoever shows up. I know that many of you are not cleared, so I don't think we're going to have all 13 trying to get in the room. If you're not cleared for attending the class yet, just watch the videos on Brightspace. You'll be fine. You won't miss anything. This is one of them. And I'll help you along. We'll get through this together. The other thing is we do have quite a bit of project work in this class, and so in the project work you will be on team. So what I'm going to do is on those days when we're going to have project team meetings, that's me and the team, whichever team you're on those days when you have to come in, we're only going to have half of the class come in on, say, the Monday. And then the Wednesday, the other half of the class will come in, and that will help us kind of de-densify the classroom even beyond what's required, because we can have 12 people in the class. Now, that technically leaves one person out, but often students, one person has to miss anyway. So, but the idea is we'll have about 6 or so on Mondays and 6 or so on Wednesdays during those days when we have project work. Hopefully all of you know me. This is an upper level course. I've taught many other lower level courses. I've probably had you in heat power or dynamics or even maybe strength of materials. So welcome back. It's good to have you. I'm not particularly fond of this online format myself. I'm sure you're not either. That's okay. We'll get through it. There are some things that may be better. I don't know. We'll see. If it were me and I were in your shoes, I'd be glad that I didn't have to drive to campus every single day, potentially. You know, it's quite a bit of gas money and time savings. So, in fact, funny story, when my mother retired, she said she was surprised how much money she saved because she wasn't spending money to go to lunch or to drive to work or upkeep on her car near as much because it wasn't near as much wear and tear. So it's just interesting that going to work or going to school all the time costs quite a bit of money and time. So I really think this is something that should have happened a long time ago. I think that higher education needed to not every course obviously, but those courses where it makes sense, if it can be done in a virtual sense and you don't, as a student, you don't have to stress so much to get out of your home and maybe you go to a park and watch the videos or something and enjoy your day, Anyway, we'll see how this goes. Please do give me feedback, by the way. Obviously, we're going to have feedback at the end of class, but also I'd really like it if you would give me feedback throughout the semester because my focus is on the course content. I'm trying to make sure I deliver everything that you need to know and that you need to learn. You're the ones that are experiencing it, and so if I do something silly and I forget to post something, or I don't know, maybe it would be better if I just rearrange things in Brightspace. Please let me know, because I can do that, on the fly. But if you don't tell me and at the end you say, oh, this is a horrible course, if you had just XYZ in Brightspace, it would have been better. Well, it's a little late then for you, right? I'll do that for the next class. In fact, I usually keep a running list of recommendations from the last semester. I've got some stuff that's, actually you could see it right now. Let me change that. I keep a course notes, basically, that I can refer to so that I don't forget to change things in the next semester. Just improvements that students recommend that I agree with. Anyway, so please give me your feedback. So this is the way you would view the course. So we're back at the syllabus. Let's go through that. Of course, here's my number. I will add my cell number. I'm purposely not at this point because I'm putting this on YouTube. My office number is going away eventually anyhow, but I don't want to bother trying to blur it out. We're meeting Monday, Wednesday, 10 to 12, room 1162. You can read the course objective. I'm not going to read it to you, but let me just explain this course a little bit to you. This is the course that you thought your degree would be all about. Okay, we get to talk about gears and belts and pulleys and power transmission and all the different machine components that you use to make up a typical machine. Just about every machine has a frame. That's where we start. About every machine has fasteners. Those two things are our topics for this first week. This is exactly the course that you probably thought you'd be studying the whole 4 years you're with us when you first signed up for a degree in mechanical engineering technology. And so because of that, most students really like this course because they feel like, finally, I'm here. Why didn't we start with this? Well, we didn't start with it because there's so much you need to understand about stress and force and power and energy, and all these things have to be understood before, and materials too. All these things have to be understood before you can have any clue about the details of machines. I mean, if you try to size a gear, for example, there's a lot that goes into that. You got to view the teeth as sort of cantilevered beams, and you wouldn't know what that means unless you had strength of materials, right, or statics. Not only that, but the materials that the gears are made from are critical. There's differences in the types of stress that the teeth experience, and therefore that they fail from. So you had to have a lot of foundation poured before you were ready for this kind of course. Now, unfortunately, the way that foundation is sort of poured for you is in a very much here's an equation, here's a problem, here's how you apply the equation to the problem, here's the answer, give me the number to the nth decimal place, the third decimal place or whatever. And so far you've been trained to believe that there's one right answer to every problem. Good and bad of this course is I'm going to turn that on its head. I'm going to say there are no right answers most of the time. Now, I don't mean that in some touchy-feely sense. What I'm saying is there are multiple design solutions that are adequate for solving a problem. Think about it. You already know this, right? If you go out to buy a car, you got Toyota, you got Ford, you got Honda, you got GMC, right? You've got options, and they're all a little bit different. Now, of course, some people take the engine out of one manufacturer's vehicle and put it in another, right? But that takes a lot of work because they don't bolt up directly. So which bolt pattern is the right bolt pattern for the engine? I don't know. The one that works, right? That's what matters. So the thing about this class that's very different from most, yes, we have some homework where you should get a particular number, but we also have a lot of, you know what, I may as well go ahead and tell you about it, a lot of what I call design projects, individual design projects. Let's jump over there real quick so I can show it to you. So if you click on homework and individual design projects, you'll notice that some of them I've labeled as individual design project, some are homework, okay? The homeworks are the ones that are more, you should get one number for this. There's a right answer, everything else is pretty much a wrong answer. But the individual design projects, these are ones where your solution may be different from mine. They may be different from everyone else in the class, and yet there are still guidelines. You can't just say, here's my solution, and because I made it pink, it's perfect. No, it still has to follow good engineering principles that I'm going to teach you for designing fasteners and frames, for example. Along those lines, the homework is not worth near as much as the individual design projects. Now, I'm not going to throw homework and IDPs at you most of the time. Sometimes there's both, that are due, because I had to try to compress the semester together. So I tried to put things together in a way that won't kill you. But I will warn you, our schedule is quite aggressive, so please make sure you keep up with your work. And I know all of these homeworks, I know all of these projects, I give them, they're the same every semester. But please, just make sure you're keeping up, okay? I've purposely tried to make it so that the workload is not going to crush you 1 week. The idea is that it should be more of a very consistent workload, okay? So there will still be some variation. Some will be harder, some will be easier. I'll try to warn you about those as we go. In fact, why don't I mention it now? The individual design projects that are more challenging, there's shafts, certainly, springs, and then at the very end, gear design. These are the, I call that a homework. I'm probably going to change that to an individual design project because that's really what it is. But anyway, those are the more difficult ones. Did I make springs? Yeah, it's an IDP. Okay. So those are the ones that are going to take probably the most time. And maybe I'll just include a warning or something in the... That's a good idea. I'll do that after I get off this video. I'll put a little blurb in here, say, warning, this is a long set. This should take you quite a bit of time. So that way you see it coming up. It doesn't blindside you. So anyway, let's go back to the syllabus. All right. So there's a little bit about the course. Of course, our objective is that you're able to size machine elements. And that's another thing that's interesting about machine design. You might think, well, I'm going to go be a machine designer, and I'm going to, every time I have to design something, I'm going to design everything down to the smallest gear tooth. I'm going to make it all work. Well, that's not really the way things go. Bearings themselves, you might think of a rolling element bearing, like a ball bearing, okay? Even those are complicated enough that there are people who specialize in bearings for their whole life. There are companies that specialize in bearings. Timken, for example. I met a guy, he was an engineer when I worked at Amatrol. He had worked at Timken Bearing, and he was telling me details of bearings that I had never even thought of. For example, he said, did you know that the balls in the ball bearings actually can be too smooth, that the surface roughness can be too low? It obviously can be too high, right? You don't want a rough, oddly shaped bearing ball rolling around. That won't work. It needs to be fairly precise. He said, actually they can be too smooth. If they are too smooth, what will happen, he said, is the balls, rather than rolling as they go around, they will slide. He said they end up wearing, they wear unevenly, and your bearing dies early. I had never even thought of that. And so when you're designing a machine, you really need to rely on companies that specialize in whatever component you're inserting. If you're working with a bearing, or if you're working with a gear, or if it's a pulley, you really need to pick the brains of the design engineers, or the applications engineers they're usually called, at the company where you're buying your machine element. And by the way, if you switch machine elements, even if it's supposedly a compatible item, say a gear or a sprocket from manufacturer A, we're switching over to manufacturer B, guess what? Manufacturer B sprockets will be different. So a lot of times that's why you switch, because you're hoping for an improvement in some parameter, whether it's cost or life, longevity, whatever it may be, maybe impact resistance. That's the reason you switch. And so two parts may look identical and yet still be quite different. So it's important that you realize what I'm trying to develop here is sort of I'm trying to retrain you, okay? Rather than here's a first principles equation, here's a problem, apply the equation kind of like you're in physics and give me an exact answer. What I'm trying to do is get you to realize, oh, every company is going to have a recipe that you follow, okay? Called design guidelines usually. Now there's design guidelines that come from many different sources. One design guideline set might be a standard that comes from a standards organization, right? Or maybe the gear manufacturer follows AGMA, which is a standards organization. You can know that you're getting a gear that would follow the AGMA standards, okay? You want that anyway, okay? But you see what I'm saying, right? So it might be that the company sets their standards for their components, or it might be a standards organization, but you need to understand that there's going to be basically a recipe that you follow. It says, okay, put in how much power you need, put in what kind of speed these things are going to go at, put in a bunch of inputs for your particular application, and out comes the gear that you should probably use. And oh, by the way, you can put in different inputs that are things you get to control on your machine, and it will give you a different gear output. So that's more how design engineering is done. You don't sit around with, you know, a lot of first principles equations and design every little detail. No, you use a manufacturer's recipe, I like to call it, or design instructions, whatever they call it, application instructions, and you just follow what they say you should do. And that doesn't mean that it's easy. You might look and say, well, why didn't you tell me this from the first day and I could have avoided 4 years of a degree? Well, the reason is because a lot of times those design guidelines require you to understand a lot of first principle stuff in mechanical engineering. That's why you needed all the courses on statics and dynamics and strength of materials and all your materials courses and all of that, because the recipes, as I like to call them, assume that you understand a certain level of, or you have a certain level of knowledge in your field. And if you don't have that, you won't even understand what the recipe is asking for, okay? Or the design guidelines. Here's the text we're going to use. The approach I'm describing here is the approach he takes. He draws from some companies' design guidelines. He draws from some standards. And there's going to be a lot of bookwork. You absolutely have to have this text. Now, I have posted the first couple of chapters of this text that you need. You know, I think about before the first exam or so. We'll see that in a second. But you got to get this book on order if you don't have it. And we do use the 5th edition. Make sure you get that one. As we go through the lectures, I'm going to have my book beside of me. It may feel a little disjointed, but I'm going to try to remember and point out all the pages you need to tab. You definitely need tabs in this class. You need your textbook. You need a highlighter. There are a few mistakes we'll correct, but there aren't too many in this book. So make sure you have those things when you're watching the video, because I'm going to point out a bunch of pages and say, hey, this one's really important when you're, say, designing a key or something like that. All right, how will you be graded? Well, all of those homework assignments that I actually call homework are 10% of your grade. The individual design projects get rolled in with a bigger design project we have later, and that all falls under the heading of design projects. That is half of your grade in this class. If you have a choice between getting the homework done and getting an IDP done, absolutely get the IDP done. It will be worth far more to your grade than the homework. Now, the homework is important. I'm not trying to say the homework is not, because you see, the homework and the IDPs do not cover the same material. The IDPs are things that I've designated work, or well, I've designated work that is a little bit harder and a little more open-ended as IDPs. The homework are things that are a little more closed-ended, where it's just, okay, apply a formula for calculating a key size or key length. You know, it's not particularly difficult. And that's why I give you less credit for it. But it's still important, because on exams you'll have to design a key, for example, even though that's what appears in a homework for exercise. Now, I say 4 exams here. I don't remember. I may have changed that to 3. We'll see in just a second. If it's 3 exams, it'll still be 40% of your grade, and they'll all be equally weighted. Now, one thing about this course and the way I grade, I do not grade based on a straight scale, but a straight scale is the worst grade you could receive. Now, I do grade on a curve, and what I mean by that is I will take all students' performance at the end of the semester. You know, your amount of work, the amount of credit you've earned will be between 0 and 100%. If you do nothing, you got 0%. If you do all of the work, you've got 100%, right? And assuming that it's all correct. And I lay those students out on, an increasing line. And then I just look for places where there are large breaks. So I want the upper section, obviously, to have A's, right? But I look for a large break in a grouping. That's what I usually see are groupings of students. And so the ones that have performed the best, obviously work the hardest, study the most, they deserve the most reward. And so those on the upper end that are sort of grouped together, those are the people that get A's. Now, I don't typically give a whole lot of A's in this class. If you want an A, you will have to work hard in this class. But as I said, most students actually really enjoy this class. At least they enjoy the topic. Sometimes the way that I've changed it so it's not a first principles class, or well, that's really its nature. Sometimes the design aspect really worries a lot of students. If you're the type of student that loves getting, the third decimal place right, and you've got the right answer, you may really struggle with this class. If you're a creative person who says, why don't we put the gear over there and just see what happens, you might actually like this class because it gives you some guidance on why that would or would not be a good idea, or whatever change you think you might suggest. All right, so hopefully you understand the grading, and there is a rule of thumb here that I've kind of noticed over time, and that is, if you want to estimate your grade and you know what percentage you've earned in the class, well then just assume a straight scale -1. So usually 80 to 90% or so is an A, 70 to 80% or so is a B, and so on. But now I won't promise that, but that's about how it usually works out. Okay. If we have bad weather, actually it probably won't affect us very much because so much of this course will be online. But if it's a time where we're supposed to come in, I'm not sure exactly how things are going to go. I know Professor Dews is going to be the one that calls it and says, yes, we're in class, or no, we're not. So just watch local media. At this point, that's all I can tell you. Let's see. Homework and IDPs are assigned and collected on the second class day. That's Wednesday this semester. I do grade these based on effort only when it comes to the homework. Now, IDPs I look at more closely, okay, because they're worth more, and I expect there to be more questions about individual design projects. Now, when you submit your work, I prefer on Brightspace, I prefer that you get Cam Scanner for your smartphone and just scan the pages with Cam Scanner. Make sure it's legible. If it's not legible, I'm not going to spend a lot of time this semester trying to figure out what the heck the little scratches are on your paper that I can't read, okay? Make sure you've done a good job of scanning. Make sure you've done a good job of writing your papers so I can understand what it is that you've written. Because like I said, I have to go through the IDPs in more detail than normal homeworks that I may have gone through in the past if you've had a class with me. If you do submit paper, note that the pages need to be in order and they need to be stapled together, because I don't want to lose a page and not know what student to give credit for. Also, make sure your name is on it. Now, if you're submitting homework on Brightspace, obviously it's submitted under your name, so I know whose work it is. But if you're submitting paper, make sure your name is on it. Also, if you're submitting work online on Brightspace, please make sure that you've put the problems in proper order, okay? Do not submit something where you've got problem numbers just all over the place. You work problem 20 and then 12 and then 8 and then 30, Put them in proper order, please. Now also, regardless of which format you submit your work in, make sure that your answers are boxed so that I know what you're trying to give as answers and results, okay? What else? If you don't submit work on time, it won't be credited. So I'm going to be more strict this semester than in the past, mainly because I'm trying to keep you on track. I know for myself how easy it is to get off track if I don't have firm due dates. I'm not doing this to hurt you, I'm doing it to help you, okay? I'm sure there's going to be so much confusion this semester with our different, required format, that it's just going to make your and my life miserable if I try to accept late work. So get your stuff done on time. If you don't get something done, don't worry about it, okay? If you're, it's midnight and you go, oh crap, I was supposed to submit that assignment, go ahead and do the work before the test, but don't bother trying to submit it. Don't bother, asking me about it. Just understand that the value in the work is you learning from it, okay? So please do your best not to miss IDPs. If you're going to miss anything, miss a homework. But even those, please don't miss. Please do complete those, even if it's not for credit. Complete those before the test. Don't just watch my videos, because I have posted solutions to all these things. Excuse me. Don't just watch my solutions and think, oh, okay, I understand, I'm good for the exam. That doesn't work. You have to struggle with the concepts yourself. You have to flip through the book and find the information and realize, oh, that's why I needed a tab there. I forgot that one, or, oh, I see why that tab page is so important now. I do intend to have quizzes, but they'll be fairly simple. They're not really concept quizzes as much as they are just seeing if you watch the video. Okay, so it won't be did you watch the video, but it will be questions from the videos. We do have work that we will have to perform in the Boilermaker lab. We have a project, and so you need safety glasses still, and I recommend a set of calipers. If you don't have those yet, shame on you, you should. Okay, you're a mechanical engineering technology student. These are tools that you're going to use throughout your entire career, I promise you. So just go ahead and get them. You may as well at this point. Closed-toed shoes are required in the lab, and you have to use the buddy system, so you have to have someone in there in case you get hurt. And clean up after yourself. Please do not leave messes. Attendance is not mandatory in the class, but it's foolish to not complete them. And basically those quizzes, those lecture quizzes, are how I'm not really taking attendance, but I'm making sure you keep up with the videos. So there will be due dates for the quizzes when you're supposed to be done with them. And those due dates will be an hour after the class period ends. Exams will be online. You can see I've crossed out my normal test being temporarily returned. And exams will be online. You have to have your video conferencing software set up on your computer. You need to leave your video camera on the entire time of the exam. Please let me know if that's a problem. But that's the plan. Okay. The final exam may be comprehensive. Usually it's not, but I'm leaving that option open to myself. I have caught students cheating in the past. Please don't. There's no point in cheating. You're really just shooting yourself in the foot when you do that. I know that sounds trite. I know it may not make a lot of sense to you right now, but cheating doesn't help you. It doesn't help anyone. I also expect you to be professional. I don't want you getting on a video conference with no shirt. That's not professional. Pretend that you're going to work and you want to look good because you want to get a raise. Okay? Professionalism is something that we need to develop in you before you leave us. A lot of times people get promotions, people get raises based on perception, right? Based on what they look like. And I'm not saying you should go out there and pretend that you do a lot of work and when really you're just lazy at your desk all the time. I'm not saying that. But you should project a professional persona or look. That is important, and that's one of the things I want you to practice in this class. Now, if you have a disability and you need accommodations, please let me know. I need your accommodation letters if you get extra time on tests, things like that. There are emergency evacuation maps. We will look at those when we're in class. They're hanging on the wall. You guys should be familiar with those. All right, so here's our course learning outcomes and objectives. You may or may not understand those at this point. That's okay. This is what I'm trying to develop in you. Here's our COVID guidance and information. Make sure you read through that. I'm not going to go through it because you've probably seen it multiple times already in classes. And here is our huge tentative schedule. Now, I will warn you, I have smashed some things together out of necessity because I want you to be able to work on your project with me to get my feedback. And if we're busy working on class topics, you won't have time to work on your project. So I've tried to compress the schedule. I know Purdue's already compressed it, but I've tried to make it reasonable. And I had some space. It was fortunate because some of the homeworks, students were kind of surprised at times that, oh, you mean that's all I have to do for this week? Well, that took me 30 minutes, no problem. So I've tried to compress things where I've not killed you by putting too much work on you, but it'll be a little more consistent work hopefully this semester, and that will leave us time before the Thanksgiving break for a lot of team design project work. Now you may wonder what that team design project will be. I'll show it to you. I've run the same one for several semesters now and I really like it. I think students enjoy it as well. And if we have the opportunity to actually build these things, it's something you can accomplish. It's something you can build in a reasonable time. So you can see the 3 exams set up, and then I typically have a final as well. But if I've covered everything, I haven't set a date for the final. That's because really the final project is a lot of work. Let's play it by ear. Let's see if we want to have a fourth exam, which would be the final exam, or not. I'll leave that. I'll give you guys some input on that part. Okay. So there's the syllabus, and as I said, if you have any questions, my virtual door is open all the time, or it's going to be. Feel free to ask, just stop by my WebEx room and ask questions. I'll post a link in the announcements here in a little while. Alright, table of contents, you can click on that if you want. I don't recommend it. It's basically just all the, let me scroll up, it's all the other stuff here. I recommend you just cycle through them. I do not recommend you try to complete this course on your cell phone. Brightspace is a little better on cell phones, and there is a Brightspace app that I recommend you get, but completing the course on your phone would be very difficult. You need a good, strong, reliable internet connection and a computer at home or a laptop or something where you can complete it, because there's just too much to do on your phone. It'll be too difficult. There are some sort of boilerplate items that Purdue has provided that I've included in the course, on the Brightspace course. It's just information on getting help. There's some hints about writing. We don't have a lot of writing in this class. There's not really any reference to the libraries. But peruse these as you will. There are some better things down here that may be more practical for you. If you need any of these services, please make sure you take advantage of them. They're a little bit harder to obtain, I think, since we're remote from main campus, but they're still available to you. Accessibility information is here. Make sure you go through this, and if you need special help in that manner. University policies are here. These are important as well. Make sure you at least glance through these once or twice in your academic career. And then here we finally get to some of the first course information. So my schedule I've posted here, so you can kind of tell when I'll be around. There are some times when I will not be around. I'm glad to get with you before these times, after these times. I'm open. Okay, I love what I do, and I love watching you guys learn. That is so much fun, because you think about it, when you want to watch a comedy movie, say there's a movie you like and you've seen it 10, 20 times. When you sit down to watch it, do you want to watch it again by yourself, or do you want to watch it with someone else? Naturally someone else, right? Why is it that it's more fun to watch a comedy movie with someone else when you're already familiar with it? Well, I think the reason is because they enjoy it, and you get to enjoy watching them enjoy it. That's the way it is for me. I enjoy this topic, but I don't sit down and read through our text just for fun. I enjoy students going, oh, that's neat, look at this, now I know how to size a gear. That's what I enjoy. That's the part, once a student has built a project and succeeded and it works, they get really happy about it. That's the part that I really enjoy. So, like I said, I love this topic, and if you're, yeah, sometimes you're going to be struggling with it, and that's when you need help, but let me help you, because then at the end I'll get to see you be happy, right? Because you came to me with a problem, now it's solved, and you're relieved, and you're happy that you understand something. That's great. That's why I teach. That is because I enjoy that. Now, there is a band of time here. I will not be available. You can see that band here from 3 to 4 or so. Well, no, more like 3:30 to about 4:30 or so. The reason is because I have to pick up my daughter on certain days, and it's just complicated to try to explain which days I have her. So I just blocked out that time to sort of take a break, whether I need to pick her up or have a break in the day for myself. I might be around during those times, but most times I probably won't. I'll probably sign off during those times. Other than that, I'm showing you what courses I have when. One of our courses is, of course, 314, the Monday-Wednesday section. And I'll either be in my office for these, or I'll be down in the room, 1162, if you're looking for me. But, of course, the first place to find me is in the virtual room, unless it's a week where we're meeting for project teams. All right, let's go back. Here's the text you need. This is what it looks like. You should be able to buy it online. It's not too cheap. It's not too expensive. It's going to be one of those probably $100, $50 to $100 books. maybe a little more. I haven't looked recently, I'm sorry, but it is a good book. I do recommend you get it, and I actually recommend you keep it. It's one of those that I do recommend you keep. It is not the most recent edition. I use the 5th, trying to help save you money, and I think I've been with this author since the 3rd or 4th edition, something like that, and things don't really change all that much. I went from the 4th to the 5th edition because the 6th came out, and so the 5th was dropping in price. And the 5th did have some improvements, a few less errors, and looked better, so I went with that. There is a course introduction. There is a presentation you need to watch. And I have not recorded that, so I'll record that. Oh, I guess this will be the presentation. But I thought I had... There's some slides. I'll go through this as well. I'll record it as a separate video. But anyway, also, this is a funny video you should watch. And if things sound like this to you in the class, please do ask me questions. It's just something lighthearted. And I thought you might like seeing this, America's Iron Giants. It's some machine elements in action, and you might enjoy it. There is a piece of software you may want to download. It's called ImDesign. And what it does is it has the design rules built into it that you're going to learn in the class. Now, don't recommend that you use this software to complete your homework and give me that as your answer. I recommend you use it to check your homework. Not that that's completely required, because of course you guys know me, I have worked through all the homework and individual design projects myself and recorded them for you, so that you know, if you get stuck, you can watch my videos and hopefully you get unstuck and learn some more. But one thing about this, you may use ImDesign on the test. Now, you can't give me ImDesign results and say, well, I plugged in these numbers and here's the answer. No, I want to see the work, but you can use this to check your answers on tests if you want. So it's worth it to learn how to use ImDesign, and you get into the habit of using it during your homework and your individual design projects, so on the exam you can check your answers. That's fine. Now, that obviously not everything on the exam will have ImDesign as useful, but there will be places you can use it and it'll be helpful. Alright, what about that project? Let's go look at it. The project is to work in groups and redesign some of the machines that were designed by a little group called Precious Plastics. So one of the things I'm going to require you to do is watch, not this video, this is more of an arts and crafts type video, not quite as impressive in my opinion, as this Precious Plastics video. This first video, I actually put it there for contrast. It's more of a, hey, let's take some lids around the house and some milk bottles and let's recycle them. Well, that's nice, but it's not really industrial scale. You might make a plastic pen or two out of it, but you're not really putting a dent in the amount of plastic that is wasted. Now, I'm not a big environmentalist to say, oh, we're bad to use so much plastic. I've got friends that hate plastic and they don't want to use, they'll go and get paper bags at the store, and that's fine. I mean, that's their choice. There's nothing wrong with that. But as an engineer, I look at the other side and think, well, wait a second, how much energy is in that paper bag to make it in the first place? You know, how much energy is in the plastic bag instead? Which one actually makes the most sense to use? And, you know, honestly, plastic bags are pretty easy to recycle. You just save them, and we probably all have the little, plastic bag container in our pantry that gets too many of them. Just grab a bag, throw them in, and when you go to the store, they've got collection bins usually. You can recycle the plastic bags if that's what you want to do. So recycling is a possible thing. Plastic is precious. It turns out, I've got a friend also who makes fender wells for Jeeps. Okay, I can't remember exactly what they're called, but he has his own little business, and he showed it to me. He's got a little shop, and he vacuum forms these fenders into they're fairly large pieces of plastic, but he sells them online. He makes his living doing this. So it's an interesting little setup, a one-man show. And he showed me the plastic, because he starts with these panels that are reasonable size, they're pretty decent size. And he has a lot of plastic waste. Well, it turns out it's worth it for him to save that plastic waste and take them to be recycled, because the amount of money he gets per pound for that plastic is more than you get for steel. The plastics is actually more valuable than steel. And so he recycles all of that material. And mainly because it makes sense, on a cost basis to do it. So, one of the things that I think is missed in a lot of these videos you see online about recycling plastic is that on an industrial scale, they typically do recycle their own waste product. So if you think about, plastic injection molds, there are usually runners and sprues, and that's wasted plastic. Well, that they take and they grind it back up and put it back in. In fact, they let their customers specify how much so-called regrind can be in a product, because some products require less than others. And so, recycling is something that already happens on an industrial scale. What happens is people see all the trash they're throwing away, which is quite a lot. It's kind of amazing if you look at how much trash you generate every year or every week even. It's quite a bit. And they feel like, oh, this is horrible. Well, yeah, it's not great, but there are options. And what I like about the precious plastics is that it's more of a, you're not just making one little pin. You can make bigger things. You can make more things, and the machines help you. Whereas this is a lot of arts and craft hands work on special machines. This is getting closer to that industrial scale application. So that's why I like it. I've included some ideas of what you might want to make, because there's two parts to this project. There's the part where you have to design the machine, but then there's also the part where you need to design a mold, or basically what plastic component you would like to make. Now, you may design an injection molder, something like this. Okay, great. You could make a mold that would hook up to this machine directly and would allow you to make your part. On the other hand, you may design a grinder like this machine on the left. Okay, in that case, you're not trying to make plastic into a mold. You're just trying to take plastic, shred it up so that it can be molded. In that case, you don't have a machine for making your part. So how do you know how to make your mold? Well, there needs to be communication between the teams, and I will publish what each team is making, so that whichever team is making, well, either one of these machines can mold parts, but whichever team is making one of these can publish their specifications. Say they've got threads on the end of their nozzle or something, and they can tell you what those size threads are, so you can make a mold that threads onto it. So there will need to be significant communication between the teams. But part of the project is to also decide what type of plastic product you would like to make, and to design a mold for it. Now, if we get the chance to machine that mold, I want you to do that as well. Okay? So there's a lot of ideas I've had here, a lot of little plastic things. I drink my sodas directly from a 2-liter. Okay, that's just, I got tired of getting out cups, and I usually go through a 2-liter a day or so. It's diet, so I'm not putting on a lot of weight. Probably still not good for me, but that's my habit instead of coffee. Okay, so I've waited. Nobody has gotten me one of these for Christmas yet. I keep waiting. But I think I'll buy one eventually. But that's something else that you could potentially make. I'm not saying make it for me, but if that's something you're interested in, that might be the component you would like to make. Maybe you drink from 2 liters as well. So a bunch of different ideas here. Here's a soda fountain made of plastic. So I'm not saying these are things you have to make. Come up with whatever you want. Why do I have a chip clip here? Let me explain that story. My daughter has really long hair, and when she was younger, she didn't really know how to brush out her hair herself. She loves her long hair, and of course I didn't want to cut it because she liked her hair, and I thought it was pretty too. But the problem is she would sleep on it and would get rats in it. And so, that sometimes she would cry because I was trying to get the rats out, and I do my best, but still it pulls, and she's fairly tender-headed. And one day I thought, no, why? Is there some solution here where it won't hurt her head? And I realized, wait a second, I've got a ton of chip clips in the kitchen. So I went and I got a chip clip, and I just separated out some of her hair and chip clipped it near the top of her head. And then as I brushed the hair below it, she couldn't feel it, because what was happening was, as you brush, it was applying force to just a few strands of hair and pulling it from her head, and that's what hurt so badly. But by clipping it together, it was more like a broom where all of the strands are together and strong, and the load could be distributed out to others, and it no longer hurt. It worked great. We were so happy with it. Well, what happened was that chip clip ended up breaking, and it turns out it was the compliant hinge. That's what this portion over here is called, where it hinges together. It's just a thin section of plastic so that it's flexible. Well, after so many flexings, that hinge breaks. That's just the nature of plastic. And so I thought, no problem, I'll go get another chip clip. And I did. Well, it didn't work near as well. The problem was that the original chip clip, when it folded together, had a very deep pocket. And so the hair went in very deep and was held very well. whereas the other chip clips just barely held the hair as well. They just kind of had ridges in them. And it turned out I couldn't find another one of the design of chip clip that I had. So eventually, someday, I want to make these. But of course, at this point, I'm so far behind. My daughter's grown up and brushes her own hair. But anyway, I've left it in here though because there's something important to know here. This chip clip with this compliant hinge is, great. It has application. But if you use regrind to make these things, the plastic will be more brittle and it will fail sooner. So there are situations, there are products that simply can't use recycled plastic. And so I was going to try and figure out a way to redesign the hinge so that it was more of a mechanical hinge where it pivoted rather than this compliant hinge, make it out of two parts, Never got around to it. So that's why it's there. That's the story behind that. So that's the project. At this point, I'm assuming that we won't be able to build this. I mean, I'm kind of a pessimist, I guess. If we can build the project in real life, we have in the past, we could do it again. I've got some industrial motors. We got 3-phase in the lab. In fact, I had 3-phase installed where we could use it for this project. Worst case scenario, I'm just assuming that we're going to have to complete our designs in SolidWorks. They'll be virtual, and the detailed mold will also be a SolidWorks file. That's my assumption, but we'll see how that goes. Now, there's a lot of calculations and things required as well. You'll notice that design computations are worth 50% of your grade in the project, and this project is part of that 50% of your grade in the class. Now, how much it actually accounts for, usually what I do is, this project usually ends up being 25% of your grade. Now, that's not a guarantee. Okay, the individual design projects account for the balance of the 50% of your grade in class. But we'll see how things go. Hopefully we'll get to stay in the lab, but what I'm afraid will happen is that some student somewhere is going to somehow contract COVID, and by through excess caution, I don't want to say excess, but an abundance of caution, I'm afraid our location will be shut down where we can't have any classes together. So I'm just trying to bite the bullet from the very beginning and assume the worst, and if things can go better, great, then that's good, okay? So our goal is to actually build this, but if we can't, that's okay. There are also some sources of machine elements that I'll talk about more. I'll probably recommend some of these to your individual team as we go. So that's the class. I'm sorry it's in the format it's in this semester. Please let me know what I can do to make it better, and I hope we'll have a good semester. Oh, one more thing. You may look at this and say, well, where's the course content? Well, I've already developed it. I just don't turn it all on at once because I don't want to overload you. I want you to be able to kind of tell where you're at and what you need to do. And one of the ways I do that is by turning on what I call learning modules. And so after I'm done here, I'm going to turn on the first learning module and go through the presentation for it, as well as the course introduction, the course introduction presentation that I've got. So there's some good material there as well. But I'll start turning on things on the left here, and you'll see more and more appear. And within those will be the videos that you need to watch for that week, and the quizzes you need to take, and your assignments, and all those things. So make sure you're watching for this. And I hope we have a good semester.